Okay.
Okay, class. So we're going to be working on number 2 on this year's AP, which will have been last year's AP for you guys. So what we know so far is we have this graph, okay, and there's this region R that the first thing on part A is we want to find the volume that's generated by R when it's rotated around the line y is equal to -2. So the first thing we need to make sure is that we know that, okay, this curve right here is f of x and this is y. So making sure that you have that conceptualized down. You have to make sure that when you set up the integral, a lot of times what people forget for volume is putting pi here. So that's always what I put first. And then you have to find, since this is a calculator problem, we know that it crosses at 0, but we don't actually know what it crosses at here. So what I would do is I would set up the graph to begin with in my calculator. When you do that, you can use little intersection, which I think if you go to analyze graph and something like number 5, you can say that, okay, find the intersection between this point and this point. So when you do that, you're going to find that this point right here is going to be 2.3 for the x value. Okay? So when we see that, we're going to say, okay, we know what our interval is going to be in terms of x here. So we're going to go 0 to 2.3. Okay, now that we have that down, we have to say, okay, what are we looking at? Because we have to rotate it around this 2. So we know that if we were just to set up the volume, it would account for everything right here. That means we have to add 2 to each of the portions that we're putting into the volume. So since this is the outer region, y equals 4, we start out with 4 plus 2 squared minus, and make sure that when you're squaring it, you don't put everything together and square it. That's also one of the top 10 biggest errors people make. And then you have to subtract x to the 4th minus 2.3 x cubed plus 4. And then you have to add 2 to that as well. Squared t of x. And because this is a calculator problem and they didn't explicitly say show each step and do all your work, you can just plug it in from there. And when you round, you should get 98.867. So that's going to be your answer for part A. Now part B is a little bit more difficult. So word for word it says region R is the base of the solid. For this solid, each cross-section perpendicular to the x-axis is an isosceles right triangle with a leg in R. Find the volume of the solid. So the interesting part about this is they say an isosceles triangle, which is sort of different because they usually say trapezoid or something else. But when you hear isosceles, you have to say, okay, so I know that I'm dealing with something that has area is equal to 1/2 base times height. And since we know that an isosceles triangle has 2 similar sides, you can just make that base squared. So when you're setting up the integral from this, you have to make sure that you're still not stuck in that, oh, is this a circle mode and you keep the pi, or try and fit it to a trapezoid. You have to make sure you follow that exactly. So what you do is you say 1/2 because you can bring that out from the equation and do the integral again from 0 to 2.3. And then you just sort of mesh everything together. You have 4 minus x to the 4th minus 2.3 x cubed plus 4. Because once again, this is the bigger, this is the smaller, and then you're going to do all of that squared dx. And that's going to get you 3.574. So when you're doing that, you just need to make sure that you don't get tripped up and then you have to, this is actually going to be a difficult problem because a lot of people probably said, okay, I need to make sure I don't make the common mistake. But actually, the common mistake was correct because of what the formula set it up as. And then the last problem was saying that the vertical line x equals k divides R into 2 regions with equal areas. So that's right here. And what we want to find now is right, but we don't need to solve an equation that involves an integral expression whose solution gives the value of k. And k is what this point is going to be. So when we see that, we have to say, okay, we see these 2 intervals. One is going from 0 to k, and another is going from k to 2.3. And it's important that you think of this not as like one entire equation, but how we can solve one side to get the same as the other side, essentially. So what you're going to do for C is, I guess I'll go over here. For C, you're going to write, okay, we know that we have the integral from k to 0, okay? And this is just going to be 4 minus f of x again. F of x is this. So we know we have that so far. Now we just need to figure out, okay, what can we make this equal to that would show that x is equal to k? And the only way we can do that is by making the integral from k to 2.3. And what's important here is, let's say if this was plus or some other equation, that wouldn't work because these could cancel out and just go from 2.3 to 0. That's why we need to make it equals. And so 4 minus f of x d of x. So whenever you see something like that, you just really need to make sure that you look at it in really, really simple terms and you don't overcomplicate it. Because you're just trying to find an ends to a mean, you're not trying to find something to solve.